Over the next few episodes, we are going to look at how zero-knowledge cryptography is changing the way we handle digital trust. To see how these systems actually work, we'll use three classic characters from cryptographic theory: Alice, Bob, and Eve. Let's say Alice wants to send money to Bob. If they use a standard public blockchain, their transaction travels across an open ledger. Anyone with an internet connection can watch that transfer happen. That includes Eve. Eve might be a competitor, a hacker, or an automated data scraping algorithm. Because the ledger is public, Eve can see Alice's total balance, the exact amount she sent to Bob, and every other account Alice interacts with. A financial system that broadcasts every counterparty and balance to the entire world lacks the basic requirements of private commerce. Businesses cannot operate if their supply chain costs and payroll are visible to their rivals. Zoom out from Alice and Bob, and this level of exposure becomes a significant operational risk for institutions. The Stellar network processes over $55 billion in payments annually. Entities like Franklin Templeton manage large funds on the chain, while payment processors like MoneyGram use it for global settlements. But the Stellar Development Foundation has identified a specific roadblock called the privacy paradox. Institutions want the speed and efficiency of public ledgers, but they are legally and strategically required to keep their payment data confidential. To serve this market, the network needs an infrastructure that can verify transactions without broadcasting their contents. That is the role Pakana was built to fill. Let's run Alice and Bob's transaction again, this time routing it through Pakana's shielded pool. Alice sends her funds into the pool, and Bob receives them at a one-time stealth address that cannot be linked back to his public identity. Eve is still watching, but her view is now limited to the facts required for network consensus. She can see that a valid transaction occurred, but the identities of the sender and receiver are mathematically hidden. In later episodes, we'll break down the specific mathematics, using Stellar's Protocol 25, that make these private verifications possible. But proving the math is only half the battle. The challenge for any service provider is delivering this privacy without taking on the regulatory liability of a traditional bank. How can a platform facilitate billions of dollars in private transactions without being classified as a money transmitter? The solution is a split-brain architecture, separating data ingestion and cryptographic verification from the user-facing interface. Therefore, assets move directly between wallets on the Stellar ledger. Only encrypted metadata and mathematical proofs pass through Pakana's notes, meaning the company never takes custody of funds. To monetize the network, users exchange the LBX token to pay for these cryptographic computations. This creates a revenue stream based on computational fees rather than asset management, allowing the system to handle high volumes without taking on custodial risks. While some transfers are simple peer-to-peer moves, regulated transactions, like a real estate escrow or a construction disbursement, require mandatory identity checks and audit trails. For these use cases, Pakana provides a specialized smart contract designed for fiduciaries who need both privacy and the ability to selectively disclose data to auditors. These organizations can license their own dedicated Pakana node as a virtual machine directly through the Azure Marketplace. This creates a dual revenue model: LBX for public network usage and Azure licensing for the enterprise. In both lanes, the assets stay on the ledger and the privacy logic stays with the software. To reach this institutional scale, Pakana uses a crossover strategy to bridge the gap between open-source development and enterprise standards. Step 1 focuses on the developer community. By releasing a privacy SDK, Pakana allows any developer to integrate shielded payments into their own wallets or payment apps with just a few lines of code. Securing these early integrations provides the on-chain metrics needed to qualify for grant funding, such as the Stellar Community Fund's Build Awards. This non-dilutive capital validates the technology and funds the expansion into more complex institutional use cases. Step 2 involves moving from community traction to serving the large-scale organizations already operating on the network. This strategy targets the specific infrastructure gap identified by the Stellar Development Foundation, providing a way for partners to shield their internal data while settling on a shared ledger. Ultimately, Pakana provides the technical layer that allows public ledgers to meet the privacy standards required by traditional finance. In the next episode, we'll bring back Alice and Bob to dive into the actual math of zero knowledge and show you how to prove a secret is true without ever revealing what it is.